In this video, I introduce the active appearance model for face image generation. Active appearance model is a statistical appearance model which controls modes, for example, happy, sad, afraid, disgusted, angry, and natural, of shape and appearance variation through a set of model parameters. The images in training dataset are labeled with landmarks. Shape parameters are obtained by statistical shape model from mean shape of a training dataset. Each training image is then warped so that the landmarks match those of mean shape to obtain a shape-free patch. A texture vector G obtained by scanning the shape-free patch is normalized by mean and variance. Principal component analysis is applied to obtain model parameters C. The correlations between shape and texture are learned to generate an appearance model. Appearance model uses the parameters C to control shape vector X and texture vector G in these two formulations. Where X bar is a mean-shaped patch and G bar is the mean texture in the mean shape patch. QS and QG are matrices describing the modes of variation derived from the training data set. Here are four modes from C1 to C4. This is the mean. This is the -3 standard deviation, and this +3 standard deviation. A shape X is generated by applying transformation where ST similarity transformation such as scaling S, rotation theta, and translation TX/TY. A texture GIM in image frame is generated by applying scale and offset, where U is a vector of transformation parameters. Appearance model parameters C and shape transformation parameters T defines the position of the model points in image frame X, which gives the shape of the image patch. The inverse transformation projects pixels GIM in the image to model GS. The current model texture is a GM. Difference between the model texture and the image patch is defined as R, where P is the model parameters. Using Taylor expansion, R is written as here for the residual R. Delta P is selected to minimize squared R. And at R0, we have this delta P, where R is calculated in this formulation. Given an estimate of model parameters C, pose T, texture transformation U, and texture sample GIM at the current estimate. Update process of the model parameters P is described below. Project the texture sample GIM into the texture model frame GS. Evaluate the error vector R, and the current error is defined as E. Compute the projected displacement delta P. Then update the model parameters P. And then we use the updated parameters P to calculate the new points X prime and the model frame texture GM prime. Sample the image at the new point to obtain is a GIM prime. Calculate the new error vector R prime. If squared R prime is smaller than E, then the new estimate is accepted. Otherwise, try smaller k, 0.5, 0.25, etc. This process is repeated until no improvement is made to the error square R. New faces can be generated from mean shape and mean appearance by adjusting the model parameters P. For more details, please check with these references. Thank you. Bye.